So welcome to the CEST-sources tutorial CEST quantification by Multi-B1-Z-spectra fitting. So if you downloaded a package, you find in the folder different files. Just open the batch Multi-B1-Z continuous wave. If you open this, you see a very similar structure than in the simulation. So we have to set up the p-struct for water CEST and the sequence parameters. This is like your starting parameters, but also the fixed parameters. So now we want to just have a look to simulate the data. So I simulate 5 Z-spectra for 5 different B1. And there's also some noise added, as you can see here. So it's just to artificially add some Rising noise. And yeah, that produces us some data. We can now fit again. So if you run now the multi-B1 fit function, then you see what comes out. So this is a function of 2 parameters, the offsets and B1. And now you get the fit results, and you see this matches this very nicely. And we also get pretty nice estimations of our real values of our simulated values, which is not a big deal, of course. Much more important, you can apply this to experimental data. And to show you this, I just added to the package figure, a MATLAB figure with experimental data. And so here this is phantom data of a phantom of 50 millimolar creatine, pH 7, and measured at 9.4 Tesla at different B1s. Yeah, you see nicely the CEST effect. And now we can use the next option, which is read data from an open figure. So this directly reads the data from an open figure. Important is that you give the B1 values in this PB1 in the right order. So the highest is the last in my plot, so I have to give the highest B1 first, and really put this in the right order and give the right B1 for each plot. So if I look again into the plot, you see, okay, these are the used B1s in the experiment. They go from 0.25 to 3 microtesla, and also R1 was measured, and I have to provide this to the fit because it's a steady state measurement, so 2.85 seconds. So this is what we have to put up here, and also in the initial value. So this is here, but more important, the frequency is wrong here now. So this is not 300, but 9.4 is 400 megahertz approximately. This is important. So now we can just open our plot. We want to read again, minimize it and read the data, and automatically it's fitted. And now you see this also works for continuous wave experimental data, and we get a K of 500 Hertz and a relative concentration of 0.15%. So there you go.